Here we have a right triangle ABC, and in this triangle, angle B is trisected, which means that it's been split into three congruent angles by segments BD and BE. Those segments split the side AC into three segments. We know the length of two of those segments, and we asked to find the length of the third segment. To solve this problem, we're going to use just two properties. First of all, notice there is a right angle, so that kind of reminds us of Pythagorean theorem. And the second fact we would like to use is, although angle B was trisected, we can find several triangles here where we have angle bisectors. And we can use angle bisector theorem to help us solve the problem. So let's get started. First of all, let's assume that the length of segment EC is x. And the next thing, let's look at this green triangle ABE. It's a right triangle, so Pythagorean theorem is applied here. This Pythagorean theorem relates three sides of this triangle, but unfortunately for us, out of these three sides, we know the length only one side, side AE, which is 7. And that gives us the relationship between side AB and BE. And to find those AB and BE, we need to use another property. Notice that BD is angle bisector in this triangle, so we can use angle bisector theorem. Angle bisector theorem tells us that the bisector BD split the side AE into two segments, the ratio of which equals to the ratio of two other sides of the triangle. So AD to DE will be equal to AB divided to BE. Now if we apply this theorem, we find that we have a relationship between AB and BE, and that's a second relationship in addition to Pythagorean theorem that we need. So we got two equations, two unknowns, which we can solve. We're going to square the second equation and express BE via AB, and then we substitute this B squared in this equation. And that gives us equation for AB squared, which we can easily solve. Take a square root to find AB, which is equals to 3 times square root of 7. We can also easily find the side BE, but I'm not doing it here because we're not going to be needing this side. The other thing we would like to know is the sides BC and the segment BD. Now, segment BD now can be easily calculated from right triangle ABD by applying Pythagorean theorem, which gives us the value of 6 times square root of 2. To find BC, we can also apply Pythagorean theorem. That gives us the relationship between the x and BC. So one equation and two unknowns. That means that we need to find another relationship between x and BC. And we can find this relationship if we look at this yellow triangle, DBC. In this triangle, BE is angle bisector, therefore we can apply angle bisector theorem here. That says that EC divided by ED equals to BC divided by BD. And that gives us another relationship between the x and BC. As in the previous case, we square this equation and get expression for BC squared and plug it in the equation right here. In this case, we just get a quadratic equation with respect to x. If we open the parentheses, combine like terms, simplify it a little bit, we get a rather simple quadratic equation, which we can easily solve to find two solutions, -4 and 8. But here we need to remember that x is the length, it cannot be negative. So the only possible solution is x equals to 8, And that is our final answer.